Hi everybody, welcome to video 2 of our Pump 101 series. My name is Emily, I'm one of the diabetes educators here at Children's Minnesota, and let's get started. So you have already watched video 1, our pump ordering process. Now video 2 is about what insulin pump therapy is and how it compares to the injections that we are currently utilizing for our diabetes management. So let's dive on in. First, I've got our disclaimers here. You can refer back to them if you need. Otherwise, we'll keep moving on. So what is an insulin pump? The basic definition of an insulin pump is that it is a small medical device worn on the body that delivers rapid-acting insulin 24 hours a day through a catheter placed under the skin. Insulin pumps have been around for a lot longer than many people realize, but lately they've become much more mainstream because they're much smaller, more discreet, and a lot more user-friendly. But let's do a quick walk through history here, just so you know how far technology has come. So our first insulin pump came out back in 1978, and it was quite the device. You had a backpack that you had to wear, 2 different IVs that were continuously infusing, and honestly, I don't even know if you could leave a clinic. I think you probably had to stay under medical surveillance, but I don't know for sure. Don't quote me on that. Now, through the years, things have become smaller, smarter, a lot more user-friendly, as I said, and now that leads us to our current pumps on the market. So today there are 3 major pump brands. I'm going to zoom in here so you can take a look and see things closer. On the bottom left, that is our Tandem insulin pump. The top is our Omnipod insulin pump. And the right on the bottom is the Medtronic insulin pump. So these are 3 major brands available here in the US. Each pump has a couple different models. And so at the end of the Pump 101 video series, there are the all about videos. So it'll be all about Tandem, all about Omnipod, and all about Medtronic that dives into each brand in depth so you can make sure you're purchasing a pump that's fitting your personality. All right, so now moving on, multiple daily injections or MDI versus insulin pump therapy. What are you getting into when you decide to pursue a pump? So as far as diabetes management goes, both MDI and insulin pump therapy utilize basal bolus therapy to meet our body's insulin needs. What does this mean? So basal insulin is insulin that is used in the background to meet our metabolic needs. And then our bolus insulin is insulin that we give in kind of spurts to cover our carbohydrates for meals and snacks, and then also to correct elevated blood glucose levels. And it's a combination of that basal insulin and bolus insulin that helps us meet our body's insulin needs to function well. So let's do a quick review of really what this means, make sure we're all on the same page. So glucose is our body's primary source of energy, and there are 2 ways that we receive glucose. One is from the food that we eat, primarily carbohydrates, and then the second is from stored glucose in our liver and muscles. And this image gives you an idea of what's going on. So in the middle, there's a red stripe, that is our bloodstream, and the green G's in the middle are glucose molecules. So you can see on the left-hand side, there's a nice little muscle and a liver, and glucose is being secreted from the muscle and liver continuously in the background, putting more of those little green glucoses into the bloodstream. Then at the bottom in the yellow square, you can see a little red symbol, and that red line above it is blood glucose level. You can see that the blood glucose level rises when we eat carbohydrates. And so it's the combination of both this background muscle and liver secretion as well as the food we're eating that makes sure our body has energy at all times to function. Now on the right-hand side, you can see a little orange square. This is signifying the cells of our body. And our whole body is made up of cells, and every cell needs energy. Cells have little doors on them that open and shut, and those doors must be opened so that the glucose can leave the bloodstream and enter into the cells. Insulin is the key to using glucose for energy. It is required to use our glucose for energy. So insulin acts as a key to those little cell doors. So in this image on the right side, there's a lot of different cells, and you can see little keys opening up those doors. On the left-hand side, that squiggly yellow thing, that's your pancreas. It's one of the cutest organs we have in our body. That's where our insulin is made. So you can see a key shooting out of it into the bloodstream because it's needed to open up those doors. Now, for that basal and bolus insulin, basal insulin is working in the background. I like to think of it as a doorstop. It's propping those doors open so that glucose can enter into the cells continuously in the background as the liver and muscles are secreting glucose to the bloodstream. Our bolus insulin opens up those doors even wider so that when there's a rush of glucose into the bloodstream from the food we eat, it has a place to go. It can leave that bloodstream and go into the cells. So both basal insulin and bolus insulin are necessary to maintain our blood sugar levels and our energy. This picture is the physiologic pathway of glucose and insulin in our body, and this is for somebody whose pancreas works well. So at the bottom, there is a glucose graph. It's the pink and red one. And the bottom hot pink bar is showing our basal glucose. So that is the liver, the muscles secreting glucose in the background so that we have a baseline level of glucose to use for energy. Then the squiggly red mountains on top is our mealtime glucose. Every time we eat, there's a rush of glucose into the body to give us more energy at that time. Now, the top portion of that graph is in green. This is insulin, and this is for somebody whose pancreas works, and this is how the body responds to glucose. So there's a basal insulin, that green bar, so that's meeting the basal glucose needs. So there's a little bit of insulin in the background at all times. Additionally, bolus insulin is secreted by the pancreas when glucose is rushing into the body. So you'll see that the insulin is lining up with the glucose, and this is how, again, somebody whose pancreas works, how it's managing glucose. Now, our goal is to match how the body is working for a functioning pancreas person. So, excuse me, with injections and with pump therapy, we are doing both that basal and that bolus insulin. We're just getting it in a little bit different of a way. So for our basal insulin, when we're on injections, you do this as a once or twice daily injection. Here's a list of various brands of basal insulin you may be using. And so this is just, that's what you give once or twice a day to meet that basal need in the background. On a pump, this is very different. A pump uses rapid-acting insulin only, and it will deliver a tiny dose every 5 minutes continuously in the background to meet your metabolic needs. So this is very different. You're only using rapid-acting insulin. However, it's being used to meet your basal needs. For injections, or I'm sorry, for your bolus insulin, it's pretty similar between injections and pump therapy. On injections, you're simply giving insulin via a pen or syringe every time you're eating or needing a blood sugar correction. On a pump, you're still giving insulin every time you eat or need a blood sugar correction. However, you simply type in a sequence of buttons on the pump to then tell it to deliver you insulin at that time. Oh, and sorry, I thought it was one point ahead. There's your examples of various bolus insulins or rapid-acting insulins that you may be using. Very important principle to understand here is that on a pump, you are no longer taking your basal insulin injection. That's because the pump is now giving you rapid-acting insulin continuously to meet those metabolic needs. So you stop using your Lantus, your Basaglar, your Semglee, whatever brand you use, and you only use your pump. Now, we do want to keep a backup supply of basal insulin at home. A pump is a piece of technology. It can fail, so we do want to be prepared for that. However, when you're actively using your pump, you are not injecting your basal insulin. Okay, so there are pros and cons of pumping. This is something to keep in mind when you're going through this process of ordering, just to make sure that pumping is right for you. A couple pros here. There are fewer pokes. So you've got that cannula, that is where insulin is being administered. So instead of injecting every time you need more insulin, you're pressing buttons on your pump. Pumps have a dose calculator where you can input your current blood sugar and carbohydrate count. it does the calculation for you, and then you just okay it to give you more insulin for that bolus. So with that dose calculator, it's a little bit less brain work, which is nice. Insulin is readily available on a pump because you're physically connected to it. You don't have to go find your insulin pen and put a pen needle on and prime and all that jazz. You're just connected to your insulin, and then you tell your pump when to give you more. So it makes it a lot easier to pre-bolus or bolus back to back if you're a snacker. You can also get very precise kind of micro dosing on a pump. Your insulin pens deliver in half unit increments, whereas on a pump, it can deliver down to a 1/10 or even a 100th of a unit. So you can get a really precise dose to really meet your body's needs. You can also set different basal rates throughout the day. This is going to be discussed in our future video series, or it's in this video series, but in a future video in this series when it talks about pump settings. But just to baseline tell you, sometimes in the background we need less or more insulin, and metabolically we just have different insulin needs. And on injections, you're stuck with that once or twice daily basal insulin injection, whereas on a pump, you can set different rates throughout the day so that there's different rates of insulin in the background based on what your body is needing, which is kind of cool. And then finally, hybrid closed loop therapy is available now. And what this means is the insulin pump is looking at sensor data and making decisions. Now, it's not an all-knowing therapy. It doesn't know when you're eating. You still have to tell it what you're doing. However, with that closed loop therapy, there is an increase in time and range typically, as well as a reduction of hypoglycemia. And so that's a really great pro of having that technology available now. All right, cons. You always have to talk about the cons. So you are attached to a medical device 24/7. This is something to really consider, especially for our younger kids who like to pull things off. You can detach from your pump intermittently for bathing, showers, swimming. Preferably you keep this to less than 30 minutes. However, there is an actual maximum of 2 hours that you can be detached at a time. You're at a higher risk of skin infection and irritation on a pump simply because you are physically attached to something 24/7. And expense can be a con for you. This completely depends on your insurance plan, but it's something to consider. On a pump, we need more supplies. The next video is all about the different parts of a pump, so you'll get a little bit more knowledge about that. But in addition to your pump supplies, you need a backup plan for if your pump fails. So you're kind of duplicating supplies at home, and it's a little bit more to manage. We also need to do more frequent blood sugar checks. This was discussed in the last video, but we want to make sure we are ready for that. And then finally, you are at an increased risk of diabetic ketoacidosis, or DKA, when you're using an insulin pump. And we'll get more into this in video 5 here in this video series. All right, that concludes video 2. Thank you for joining me, and I'll see you for video 3 shortly.